All right. Good morning, good afternoon, good evening, everybody. My name is Mike, and welcome to the Architect Podcast brought to you by UnknownTech.io. So, thanks for joining on another Saturday. I hope you're having a great spring so far. Today is Saturday, June 7th. It's 11 a.m. Eastern Time. And today's episode, we're really going to talk and focus on how to bring your AI solution from ideation to value. Okay. And this is where we see a huge gap, especially in the customers that we're talking to, is they're either thinking about things or they have an idea what they want to do, or they're testing the waters in AI and they are doing POCs, or they're going to the cloud and doing POCs, or they're testing things. And what happens is getting from that phase into value has been extremely hard. And it really is around this whole idea of having this AI center of excellence. We talk about the cloud center of excellence. We talk about a cloud framework and those things. The same applies for AI. And the reason why that is because you have to get all of the players that are involved, right? All the players that need to be involved should be part of the overall AI strategy, from the business side, from the end user side, right? From the technology side, from the governance side, the financial side. All these players have to be involved, and you can't do that unless you have an organization set up for success, right? The same reason why we saw cloud in some cases fail or have a hard time being adopted by customers is very similar reasons why we're seeing AI having this hard time being adopted. And what I mean by that is taking it from ideation to the value side of it, right? Because at the end of the day, ultimately, that's where you want to get to, right? You want to extract value out of the investment that you're making. And of course, AI is an investment, right? And in some cases, it can be a significant investment. And as you scale, it can be even more of a significant investment. And we'll talk about some of that a little bit later. So, Nutanix, what we have done is really, let me, before I start and get into the actual subject, of course, I have to always go back and say that I am streaming to both LinkedIn and YouTube. And you can see here on my caption here that I do have a link to the YouTube channel, which has better quality, and you're able to actually chat and ask questions as well. So feel free to, if you want to take a moment, if you're on LinkedIn, you want to head over to YouTube, you could do that. LinkedIn doesn't offer chat capability through my streaming service, so you can't chat there. You can certainly reach out to me on LinkedIn, however, through messaging or whatever, and ask me questions, or if you have any questions, or if you want more information, I certainly will be happy to help you. But please think about this really quick and look at this and try to transition over to YouTube if you can, to get more of a better quality and more interaction. So I'm just going to bring up what we call, we have our portal, right? And I've showed you this before in past cases. And if you click the hamburger menu in the top left, you'll be able to actually go down to documentation, and you'll be able to scroll down into what we call Nutanix Validated Designs. So, Nutanix Validated Design is really focused on specific foundational validation. So what I mean by that is we have a hybrid cloud validated design, right, which includes all of the validated design, the software versioning, tested at scale to include disaster recovery, extensibility into the cloud. We have VDI designs, databases as a service designs. And what I find critical with this in most cases, in 90% of the cases, that all the other use cases are built really off of the hybrid cloud design, right? It really starts at the foundation. The same thing applies with the Nutanix GPT in a box validated design. And that's what I'm going to be covering today, because, the ask, right, or the problem statement is, how do I get from ideation, POC, right, or even ideation to POC to value? And what I mean by value, I mean production, okay, and to extract value from my AI initiatives. And so Nutanix has created what we call the GPT in a box with Nutanix Kubernetes platform, Nutanix Validated Design. And it really provides you this enterprise ready solution that contains a full stack. And so last week I talked about, or the last episode, it wasn't last week, but the last episode, I talked about the different ways that you can consume Nutanix Enterprise AI. And I also mentioned in that the one way to consume Nutanix Enterprise AI was to buy a full stack platform that includes Nutanix NAI, right? Nutanix Enterprise AI, as well as all of the underlining pieces and integration to make that production ready. Okay. And that's what we're going to focus on. Even though you can consume NAI in different ways on your own Kubernetes, your own infrastructure, or in the cloud, right? On a cloud native solution in the cloud, as an example, you have that choice and flexibility. Most customers opt for the turnkey full stack platform because of what I just said. And again, it goes back to this idea of turnkey. What I mean by that is having a full stack that can deliver all of the infrastructure, accelerated computing, the infrastructure service capability, the cloud native Kubernetes side of it, the data services side of it, and of course, layering the Nutanix Enterprise AI platform service on top of all of that, giving you this fully integrated stack that you can deliver in production. And that's what this NVD focuses on, right? It focuses on that stack. And we're going to walk through some of this. I'm not going to go through the whole document, of course, that'll be boring, but I'll walk through some of this because at the very core of an NVD, whether it's the GPT in a box Kubernetes platform or the hybrid cloud or EUC or database as a service or any of those, or files, right, or unstructured data, any of those, right, it's really formatted the same way. Okay, you have an executive summary, what we're trying to deliver. We get into the software versions, okay, of what we tested against. And this is important too, because even if your design, right, that the design for you doesn't necessarily match what we did here in a validated design, we know the interoperability of the software versions and we know it works at scale. And that's what we go with. So when we go into a customer and they say, well, what software version should we be using? We're going to recommend these software versions as it pertains to the validated design because it's been validated, been tested at scale, right? And it's one of these things that, we're very comfortable with. It's a de-risking process, right? That's the whole point of it, is to de-risk the process for you. It's also there to say that, okay, all these solutions work together. Remember I talked the last time about other solutions having a reference architecture of all these disparate components that you have to stitch together, and then they call it an AI factory or they call it an AI platform, where Nutanix is fully integrated, and that's the difference. And I'm going to show you what that looks like here in a little bit. So we talk about software versions that we tested, right? And I'm going to map this out because you're like, well, this is a lot of software. I'll map it out just like I did last time. It's going to be a repeat, and I'm going to kind of flow into what Nutanix views as the Nutanix AI factory. It doesn't have to be just Nutanix. It could be Nutanix and Dell AI factory. It could be Nutanix and Cisco AI factory. And we'll talk about some of that. And we'll talk about what NVIDIA brings to the table. We'll talk about what Hugging Face brings to the table, or even the ability to import models outside of those model repositories like NIMS or like, NIM or like Hugging Face as an example. But also, the fact that we can layer in Gen AI and ML deep learning, right, from your data lake, from your data sets into the Nutanix AI factory. And it's very flexible, right, in a sense that you're able to leverage and partner with the folks that you want to partner with. So if you want your accelerated computing, driven by Dell, so be it. We don't care. The reality is, we're a software company, right? We will run on those platforms, right? Same thing with Cisco UCS, right? Or HX as an example. Same thing with other solutions as well. I mean, you could go to Lenovo and you could get accelerated computing from Lenovo. You can get accelerated computing from anybody, right? It has NVIDIA GPUs, or maybe you're using Intel AMX technology. We can talk a little bit about that later, which we also support. And soon supporting AMD solutions as well. The idea of having competition in the GPU space and the accelerated computing space is good for customers, right? Anytime you have competition, it's good for you, right? So our goal is to support all of that and give you flexibility and choice. So let's talk about really the core infrastructure design, right? We really focus it and we really provide requirements down to the component, right? And we talk about management. What does the management layer look like? What does business continuity and disaster recovery look like? Performance, of course, right? Support GPU pass-through, of course, accelerated computing, and provide high bandwidth, low latency networking. And we'll talk about that. What does the environment look like, right? Scale, right? So even though we say that we can provide you this like stack, well, that stack may be good for a POC, but as you scale, what does it look like? Well, for example, you may want to have a dedicated storage solution outside of the stack that you connect to because you have tons of data and you're scaling, or you have AI applications that are scaling beyond, at the edge, and you're moving into the edge as an example, right? So it's not like this stack where you're bound by this unified stack that you have to just sit there. Remember, our solution is software and it's licensed software. So if you have to run at the edge, you can do that. If you have to disaggregate the storage from the stack, like from the cluster, and it have its own cluster for performance reasons or scale reasons, you can do that. If you want to have your Kubernetes platform management construct in a different layer, right, from a management perspective, and the workload clusters just sitting on the stack, you can do that as well. So you have the capability to be very flexible, and we could design it to your business needs. That's the beauty of it, right? The validation part really is around the foundational aspects of it, right? That we validated, and we validated at this particular scale, and for some of these use cases. So, for example, in this NVD, we validated a showcase of generative AI applications and RAG inferencing and ingestion workflows. Okay, so when I mean RAG, I'm talking about retrieval augmented generation, meaning using your own data, ingesting your own data, right? Not fine tuning your model, but in using a standard model and then ingesting your data, creating a vector database, right? And embedding, right? Creating those vectors in the database, right? To be able to have the solution hit that database and provide the correct information, or the information that is applicable to what you're trying to do in your information, your data. Okay. So that's another use case that we actually leverage for the NVD. And of course, it promotes this centralized, we call fleet management, because, 90% of AI is going to be running on a Kubernetes stack, right? In containers, right? NVIDIA delivers, right? Their microservices, their NVIDIA inferencing microservices, right? NIM in containers, right? NEMO, the same thing. So, and by the way, we talked about the reason why Kubernetes is great. There is an article on unknowntech.io that I talk about for the reasons why Kubernetes is the operating system for AI. And I hope you go and check that article out, but it really lays out the foundation around scheduling, scaling, resource management, all of those things, right? And serverless technologies, which we'll talk about here in a little bit, right? All of those things can be brought to bear via Kubernetes. And you need a Kubernetes control plane, right? Fleet management to actually handle that. And of course, this simplifies the provisioning of the stack using the NAI on Kubernetes platform workspace catalog application. So in the previous NKP and NAI presentations that I did, or live streams that I did in the past, which you can actually go to unknowntech.io and actually click on those, you'll find the live streams, all the links to the recordings. You can actually click and go back and look. I talk about and I show you the deployment of NAI is easily done through the NKP catalog, right? So now you have blueprints basically within the catalog. They can deploy all the prerequisites like Knative serving, Kserve, the NVIDIA GPU operator, Istio service mesh, and the NAI application itself, the platform service itself, all through the application catalog. And that's going to get easier, by the way, over time. So this idea of you having to install all these pieces separately, even though we made it simple, we're going to combine that into more of a full deployment capability in the not so distant future. Okay. So going back to this, right, we talk about the resilience, right? Provide enough GPU resources to run GPU enabled workloads in a failure scenario, right? You have to accommodate for failure. It's a use case. And so you're going to have nodes that have multiple nodes that have GPUs. And to accommodate for those failure scenarios, you have node failure, what happens, right? Well, I need to have another node that has GPU capability in order for us to continue on with our Gen AI or agentic AI applications. And of course, the hardware is extremely important. Accelerated hardware, accelerated computing we talk about. That's what it is. And as a matter of fact, as we move into the future, you're going to see more about accelerated computing, not just on the GPU side, but also on the network side. When we start looking at DPU technology, right? RDMA, GPU direct technology, those types of things. It's accelerated computing, not just from a GPU perspective, but across the board. Networking, storage, um, and um, and compute. And of course, networking is extremely important. In this case, we use servers with 100 gigabit network uplinks. Okay, use NVMe disk for optimal performance. That's a no brainer, right? We're going to use the best performing disk and storage technology, and that today is NVMe. And then, of course, we get into the monitoring, so the operational aspect of it. How do we monitor? Where do we send our logging to? What does our centralized monitoring stack look like? And then we get into security, obviously using role-based access. So this is giving you a blueprint of how you deliver this stack, right, into your data center. So I'm just going to scroll. I'm not going to, like I said, I'm not going to go through all this. I'll leave this to you guys. And by the way, even if you don't have a portal account, you can still see this NVD. You can actually get there and you should have access to at least the solution documentation. You don't have access to like downloads or anything like that, of course, but you should have access to the solution documentation. Okay, so then it gets into details around the cluster design, et cetera. So I want to talk about this, and this was the picture I showed in my lead up to this, right? In my preview to this live stream. And this picture really kind of outlines what this looks like. And you can see here we have this, regional and availability zone perspective. And it goes back to, I think I've talked about this before, but a lot of customers are hybrid and they're moving to more of this hybrid approach. And by doing that, they want to unify the nomenclature and how they architect things and what they call things, right? So they're not calling data centers, data center, New York anymore. They're calling it, US East, DC, right? And that aligns to maybe US East 1A or something, or, in the cloud as an example, right? And so you have these availability zones, which are just data centers, the same as the cloud, right, in the customer's um, premises. And then you have the regions, of course. And then, of course, what is GPT in a box 2.0? And I'm going to map this out in here in a minute. But at the very basic, it's really running our hypervisor on a platform, right? Our Nutanix hyperconverged platform, whether it's running on Dell or Cisco UCS or whatever. And then layering in the management capability of Prism, the cloud native capabilities with our Kubernetes platform, and then providing the storage and data service capabilities required to feed data into your AI workloads. Okay, whether that's for model storage or your data for like a RAG application, and we'll show you what that looks like in a minute. And then, of course, we go through cluster size, what we recommend from a CPU architecture. And of course, this can change based on your requirements, right? I mean, obviously, what you see here doesn't fit everybody. And a matter of fact, I would argue it doesn't fit anybody. What it does is it gives you a foundation to build off of, right, to make it easier. Minimum cluster size 4 nodes, sizes 4 nodes, cluster expansion in increments of 1. Don't move beyond 16 nodes. Now, this is 16 nodes is not a limitation of Nutanix. This is basically what we find a comfortable level from a maintenance perspective, as an example, or a fault domain, right? So looking at both, the size of your fault domain, your maintenance windows, all of those things, maybe it doesn't make sense to go over 16 nodes. You may go larger than that, but in this case, we only tested 16 nodes. And we're using 100 gig network we talked about. We're doing a replication factor of 2. That means 2 copies of your data, 3 copies of your metadata. And obviously this could change. You may ask for 3 copies, but what I'll tell you is we give greater than 5 nines availability, even at 2 copies. So most of our customers go with 2 copies of data. Plus, we have data reprotection, right? Or data reprotection, where if a node fails or if a disk fails, we immediately start reprotecting your data to get you back to that 2-copy or 3-copy state. Of course, we are guaranteeing high availability and enabling VM high availability. I had a little slip up there. Not a VMware, but a VM high availability. Then it gets into cluster resilience, capacity. And again, like I said, I'm not going to go through all of these things, but just some of the relevant things, like how do you lay out your storage, right? So and what technology should you enable from a data reduction perspective, right? So for example, we call our data source containers. Some of these containers are built in, like the Nutanix management share and self-service container. They'll be created, as well as the default container. Those will be created automatically for you. And then when we get into the unstructured data services like Filer and object services, S3 object services, these will also be created automatically during the deployment of those services. It lays out the data reduction technologies that you should enable or disable on each of these data stores. Talk about sizing. Again, we get into node awareness, right? What is our availability domain for a cluster? Is it node? Is it rack? Your environment could dictate a rack level awareness. And so that could be a change to this, right? That could be an augmentation to the NVD. So again, we're not forcing you into using exactly what we say that we validated against, right? But we can augment and change to the design that fits your needs, okay? Now we get into network design. Of course, we always talk about leaf spine being optimal. And in this case, in the use case of GPUs and AI, we're talking massive data ingest, massive data reads and rereads, as an example. And we're talking about having massive throughput, a large amount of throughput to support that, especially when we start talking about like GPU Direct and things like that. And that's why we went with 100 gig networking. And we also do support, Mellanox, et cetera, from NVIDIA. So those things are also supported. And we have some integrations there, which I won't get into today, but there are some integrations there as well. You may be thinking to yourself, well, Mike, what does this look like from a server capability? I'm going to touch base on that a little bit, because you may be asking, well, what about HGX and DGX? Do you support the NVIDIA solutions at that layer? And I'll talk about where we're going there. There is a roadmap for that. Of course, DGX has, there's x86 solutions, there's ARM, Grace solutions from NVIDIA that are ARM based. And those are roadmap solutions that we're going to be able to support as well. Okay, so I'll keep on going. Then we get on to the data services side of this. What does the Nutanix files and object design look like? And again, I'm not going to go through this. I'll leave this for you guys to actually look at. But I wanted to get down to the large language conceptual designs, right? Because as we get through Kubernetes and all those things, you have this large language model research workflow as an example, which we're going to talk about here in a little bit, and a little bit more. But essentially, we're showing you exactly what the design would look like from a RAG implementation, right? So at the bottom left, you have your application, which actually runs on NKP, right, in a Kubernetes cluster. And that application, right, then actually flows through a UI, right, and goes into create an embedding query of your vector database, which is serviced from a objects bucket, right? So you have your vector database, and the persistent storage is on an S3 bucket that we support through Nutanix objects. And then that retrieval is done, and it's augmented, right, with a similar content to receive the response. And this is your inference API connecting to the Nutanix files, basically, because the Nutanix file share is actually delivering the model into the GPU memory. Okay, so that's why this shows this a little bit. It's a little bit confusing, but this is kind of the flow of how you would do like a large language model research workflow using retrieval augmented generation. And then, of course, you get the answer back as it pertains to your data. So you're using a default large language model, whether that's from Hugging Face or NVIDIA, or you're using a third-party model that you've uploaded, but you're augmenting that with your data through the retrieval augmented generation process. Okay, meaning you're not taking the time to fine tune because maybe you have a smaller data set and it makes more sense and it's less intensive and less cost to do retrieval augmented generation instead. Whereas fine tuning, you're gonna have to go back and you're gonna have to have some compute for that, and that's at a cost. Generally speaking, if you're fine tuning, you have larger sets of data that you need to fine tune the model against. In a retrieval augmented generation solution, you're looking at a smaller subset of data that you want to augment the world model that you're using. Okay. And then this talks about the document ingest workflow. So again, using uploading the your data, right? Your user data, whether it's documents or spreadsheets or whatever, video, could be anything, into buckets, right? And then using this Kafka framework, right? Very similar to, not very, but similar to how an AWS framework would use Lambda as an example, right? You have a messaging queue, queue kicks off the job spins up Lambda, serverless compute, completes the job, shuts it down. Very, very similar, okay? Except you're doing this on-prem and you're doing it within the Kubernetes layer, right? So you're ingesting the data, right? Kafka gets notified, consumes a message, spins up the serverless solution, right? Stores the documents in the vector database, right? In the database itself. And then, of course, the persistent storage for that database is in another S3 bucket running on Nutanix objects. And these are called Milvus. This is called Milvus. And then now you have, now you basically are preparing the data, right, to be used in your AI workflow. Okay. So again, we're giving you designs. We talk about backup disaster recovery, how you should support that. And then we even get into ordering. Like, what do you think the bill of materials looks like? Like in this case, we're using Lenovo, right? Or HPE or NX, right? As an example, could be Cisco, could be Dell. And you're looking at what do the configurations look like? And we show you some of the configurations. And again, this may change based on your requirements. More than likely, it will change based on your requirements. But we're giving you a foundation that you can build off of. Meaning, I don't have to go and say, okay, I need this server, I need to build this CPU, this memory, this storage, these GPUs, et cetera. And by the way, we have the L40S in here. Of course, there's the H100s, A100s, and then Blackwell's inbound, right? L40S is very popular from a price perspective. So, for example, the L40S gives you this floating point 8-bit tensor capability at a very reasonable cost. Now, you don't get the ability to do MIG or anything like that. So you're not getting multi-instance GPUs, or anything like that capability. But we're talking the difference between $12,000 and $13,000 to almost $30,000 for an H100 as an example, right? And you're getting very, very good performance per watt per dollar on the L40S. That's why it's extremely popular in the enterprise, right? We always hear DGX and HGX and all these big, and Jensen's out there talking about this Blackwell infrastructure and how his spine, the networking spine within that is basically the entire, pushes the entire internet in throughput through a single rack. And that's great, but that's for hyperscalers, right? That's not for, generally speaking, not for enterprise, even large enterprise. I'm not saying that you would never get a DGX or an HGX, but I'm just saying, when we start looking at those architectures, very, very expensive. Those are for creating models, right? Actually creating models or, and doing those things, right? We're talking about inferencing. And inferencing is very good in the L40S. And you may be thinking too, you may be asking about like NVLink and all those things, right? Well, inferencing itself doesn't require a lot of throughput GPU to GPU from an inferencing perspective, right? Now, when you start talking about training and you start talking about creating models and doing that, then NVLink matters. GPU to GPU communication really matters at that point. Okay. So it's okay to go through PCIe bus as an example and not use NVLink as a, for an inferencing perspective. Okay. But I kind of went off track there, but we're just kind of outlining, okay, the L40S is very popular, great bang for buck, right? You're not getting HBM memory either. You're getting, I think, GDDR6, right, memory. So you're not getting the high bandwidth memory that you have on the H100, but you are getting GDDR6, and it's pretty robust. Again, it's always about, AI is about, an AI token delivery is really about tokens per watt per dollar, right? And what value am I getting out of that? That's how you have to look at that, right? As much as everybody wants H100s or DGX or an HGX in their environment, more than likely that's not feasible from a cost perspective. Okay. And then we get into the GPT in a box cluster if you're using NX, if you're using Dell, if you're using Lenovo. We have these NX 9151 G9s, right, that support up to four GPUs now. So we have this capability, and you're going to start seeing more platform capability from Nutanix, and even our partners, right, come out to have more capabilities, right, from a GPU perspective. And then what software do I need? Well, the software is part of this, right? This is the software that's included, and this is another beauty. This is a bundle, right? Meaning you're buying one SKU. GPT in a Box Full Stack Ultimate License contains the following: NKP Ultimate, which is our Kubernetes platform; NCI Ultimate, which is the infrastructure, right, and storage services; NCM, which is our control plane management and operations framework; NDK, which is our Kubernetes data services for disaster recovery, so for persistent data, replication, etc., and using that for disaster recovery, cloning, snapshots in cloud native, right, on Kubernetes, right? NUS is our data services, our unstructured data services for files and objects, and NDB is our database as a service to house things like the vector database and manage them as a service capability. So in that one SKU you're buying, right, the GPT in a Box Ultimate license, you're getting all of this capability. And I know you're saying, oh, I got to stitch all these things together. It's very, very simple to deploy all these things. Okay. And then NAI brings it all together through orchestration and automation. And I know I've done a demo on this before, and I did a couple demos on NAI, but I'm going to redo that again to show you some more advanced capability. But since we had just released 2.13, or excuse me, 2.3 of the NAI platform, and so we, we integrate all of these components through the orchestration automation using NAI as an example. And then what professional services do I need to make this work? Because again, anybody can come in and sell you infrastructure. The question is, how do we get you ready to consume? People always ask me all the time, what is the installation cost? It's not the installation cost. Installation is the easy part. Anybody can rack and stack, plug some network cables in, and run a tool to deliver the solution, right? But what about operationalizing it, integrating it within your data center in your operations? Everybody we talk to has different tooling. Integrating it into your tooling, your management framework, your NOC, your security, right? All of those things all have to be part of ready to consume. And then when you're done with that, then you can start looking at the AI ML design, right? Going through that process. And so the important part to me is to get everything ready to consume. And when I say ready to consume, I don't mean installation. I mean, you guys are our platform is integrated in your environment fully, right? Maybe you require incident response through ServiceNow. What does that look like? That's part of that. That's what I mean by ready to consume. Okay. Then you can get into, okay, now it's time to do the AI ML workshop and get into building, the platform and the services for AI that you meant to use this for. And they're outcome based, right? They're outcome based services, meaning that we expect an outcome, an agreed to outcome, that Nutanix delivers the services, and there's an expected outcome and agreed to from both parties, right? That's what I'm talking about with partnership. That's not, again, we're not jamming down your throat. Oh, we're gonna do this, and this, and that's it, right? It's an agreed to outcome of what the expectation is. And if we have to adjust, we'll adjust. If you need more services, so be it. You have to get more services, right? If the outcome dictates that, that's what we have to get to, right? It's all about de-risking, getting the platform ready to consume, and then getting you to value, ideation to value, right? That's the whole goal of the NVD. So again, I kind of glossed over this a bit. I went through it very, very quickly, but the reality is, it's really building this foundation, right? This enterprise ready foundation to get you to that value perspective. So it's very important that anytime that I work with large enterprise and global customers, this is expected, by the way, in those customers, right? When you go into a small enterprise or a mid-sized enterprise, they're not necessarily asking for validated designs, but we should be, obviously I'm always talking about this, no matter the size of the customer I'm talking to. Generally speaking, I work in larger enterprise customers and global customers. And so this is always talked about, right? And always leveraged in some sense. Could be even just for, may not even be the design. Could be just for the software version, right? And we're saying, okay, you should be using the software versions because we know that they work and they work at scale and they've been validated. Okay, so let me get into the whiteboard here because I want to talk about what everybody's talking about, and that's this idea of an AI factory. And I'm going to start at the GPT in a box solution, and I'm going to attempt the whiteboard again, so bear with me here because it's the whiteboard. I remember last time it wasn't that great. So I'm going to start over on the right side here, okay? And I'm going to just create what we call GPT in a box, okay? I know it's horrible. I'm a horrible draw. Okay. Now, it starts obviously at, in your environment, in your availability zone. We talked about that. Okay. So let's just assume that we're over here. We'll call this AZ1. This is your data center that we're in. Okay. And we're creating this platform for your AI workloads. Okay. So over here, we're going to come in here and we're actually going to create 3 things at the very foundation. So we have compute, storage, and networking. Okay? And all of this is accelerated. Oh, I spelled that wrong. So let's just call this accelerated. And we could say it's NVIDIA accelerated. Could be accelerated through other means, but for the most part, today it's NVIDIA accelerated. People are asking for NVIDIA accelerated compute. Okay? The storage acceleration, right, could be GPU direct. So the compute side of it, right, could be GPU. This could be GPU direct. And the networking side could be, Mellanox RDMA. So we'll just say RDMA, right? And all of this combined gives you this accelerated platform, okay? But really what this is too is it's running Nutanix, right? So this is all Nutanix AO, running on Nutanix, right? Excuse me. This is all hardware that Nutanix runs on. Okay, so this is your accelerated compute, your servers. Again, doesn't matter if it's Dell, Cisco, Lenovo, I don't care. If you want HPE, if you want Lenovo, you want Dell, so be it. Don't care. Okay. Again, Nutanix is software, right? So it runs on anything, right? Then you have your storage, right? You could be using GPU Direct. We'll talk more about that in a minute. And then you have your networking, and that could be your Mellanox, could be a Dell solution, could be a Cisco solution, but essentially, enabling things like offload, like RDMA. Eventually, you'll start seeing more DPU capability here, right, in the future with Nutanix. All right, so being able to support DPUs like NVIDIA Bluefield 3 is an example. Those are things that we are looking at to support in the future. And customers are asking for that, right? And by the way, AI workloads are dictating that we go that way as well. So it's the use case now dictating what we should be designing in technology, right? Now, the hyperscalers have been way ahead of the game here, especially AWS with Nitro. AWS has been way ahead of the game here with accelerated with DPU technology, right? They have Nitro for acceleration of networking, storage, security, etc. And eventually, you're going to start seeing this become pervasive in the data center. Even the accelerated compute piece, meaning most of what you buy will have accelerated compute already in it, whether it's built in the CPU on die, on chip like AMX Intel, or whether it's third-party GPU support or advanced networking features or storage features, right? And DPUs as an example. So what runs on top of this, right, is Nutanix Cloud Infrastructure, right? So let's just go over here, and we're going to talk about this. Put this box here, and we call this NCI. So that's Nutanix Cloud Infrastructure. And what that is that is the hypervisor, right? So that's basically Nutanix AHV and Acropolis operating system. So you're getting the hypervisor, you're getting the storage, like the hyperconverged storage stack underneath, and you're also able to get other things like flow networking. So if you need security around microsegmentation or disaster recovery capability, all of those things are included in NCI, right? So that's basically your enterprise grade software defined data center foundational services. Okay, let's just call it that. Then above this, you have what's called NKP. Okay. This is your Kubernetes services. Okay, so this is your Nutanix Kubernetes platform. Okay, and how this works is NKP interacts with NCI using Cluster API. We call it CapEx. Okay, so when NKP deploys nodes, worker nodes, or control plane nodes, it needs infrastructure. And so what we do is we call NCI through CAPI to deliver that infrastructure for us. Okay, and essentially that's how we're able to kind of automate that piece. You don't need Terraform or Ansible or any of those things. Cluster API will take care of that for you. So as you deploy your Kubernetes clusters on Nutanix NCI, right, you will get cluster. You'll be able to use Cluster API to do that. And as a matter of fact, I just want to go back here too. It's not just NCI, right? It's also NCM, which combined is NCP. So NCM is the management solution for our hybrid cloud infrastructure, right? Our NCI solution. Okay. NKP will have a control plane too. This control plane, right, will be the fleet manager for all your Kubernetes solutions and your deployment capability for NAI as well, right? So if you want to deploy from the NKP app catalog, you can deploy the NAI services, and I'll kind of map to that here in a minute. The next layer you have is your data services layer, okay? So you're probably asking, well, Mike, you said I had data services with the HCI solution. That's true. Okay, you do have data services there, but those are block services. Okay, so we're basically giving you HCI block capability for virtual machines and containers. Okay, What I'm talking about with data services is unstructured data. So we have what's called NUS and structured data, NDB. Okay? So NUS does files and objects. Okay? NDB is databases. Okay? And they all are consumers of NCI. And I know this is going to be confusing, so I'm kind of going, down a rabbit hole a little bit. This is not kind of the intention of this. The intention was to show you what the AI factory looks like, but it's important for you guys to understand, as I talked about the NVD for GPT in a box, what exactly do we have and how is it leveraged? Well, NUS, right, uses NCI, right? So we basically take the block storage and we use that as the backing for files and object services. Okay. Now these are all appliances, right? So let's just talk about this for a minute. These are all either VMs or containers, right? Appliances, right? Applications that run on the platform on NCI that consume the backend infrastructure of NCI. Same thing for NDB. NDB will also consume NCI as well. And there's automation there, right? Basically, NDB, you create your Postgres as an example for maybe you're using a vector database and you're using Postgres vector database to do that. And you want to automate lifecycle, manage that database. You want to have the ability to do copy data management, right, for test dev use cases. NDB will orchestrate all of that, but it's using NCI in the back end, right, to do that. Very similar to how Amazon, right, AWS, RDS leverages EC2 and EBS. It's the same thing, right? I'm not saying the same exact thing, but the same idea, right? NUS and files, same thing, right? We are leveraging NCI block services, and then NUS is presenting those, using those block storage in HCI, right, as a back end to the filer, whether you're using NFS. In this case, we'll be using NFS or SMB, and of course the object services as well, right? And the object services are a little bit different because they're deployed as containers, and so we use, right, CSI, right, to actually integrate the storage into those containers. Okay, now that you have all of those pieces, components, you're now ready to layer on Nutanix Enterprise AI. And this is what we're going to do here. We're going to layer that in now. And I'm going to make this a little bit bigger because I want to talk about what an AI provides you. So this is your NAI AI. I know. You're like, why are you saying that twice? AI factory. Okay. And within this, you're getting inference services. You're getting model repositories, so LLMs, right? You're getting security controls, and you're getting day two operations. Ops. Okay? So this is your platform service capability for delivering your models, right, and your inference endpoints to your applications. And that's what I want to talk about next, because this is where obviously you come in, right? Or our partners come in. So partners like Codium or Data Robot will come in and help with Gen AI apps or Gen AI. What's the new term everybody's talking about? Agents. Okay. And this is where you're going to build on top of this, right? And you're going to connect. So your apps will connect to your LLMs. Your agents will connect to your LLMs, right? And that's what we're really providing you, right? The ability to kind of manage all of that, but deliver it as one component. Because NAI, in order for us to deliver LLMs, we have to store it somewhere. So we call NUS, right? and files, and we have to store those models somewhere. So when we download the models from Hugging Face and or NVIDIA NIM, right? Or if you upload a model, right, we want to ingest that into our data platform, NUS. If you have data that you need to feed back into the solution, objects as an example, you may have user data that you're feeding in for RAG. I know this is kind of messy. Well, that data is going to be stored in S3. Or if you're using RAG and you need a vector database, right, I'm going to use Nutanix NDB connected to objects or my vector database sits, right, for the persistent storage. And so you can see now all the integration I'm talking about, right? And of course, NKP is also going to leverage NCI because now I can now push the accelerated computing up in through pass-through, right, into my Kubernetes containers. And now I have all this accelerations, GPU acceleration and GPU node pools for NKP as an example, that now give me the ability to have accelerated compute right within the platform. All of this is done and managed, right, from an AI perspective here. Your Kubernetes layer will be managed here. Your infrastructure layer will be managed here. Okay? And this gives you delineation and brings people together. And this is the beauty of the platform here. And here's the reason why. Your infrastructure folks still matter. So this is where your infrastructure folks live, right? From NCI down. Your storage team, right? NUS. Your DBAs, NDB. Your data scientists here. Your developers here. All of these teams are brought together under one platform. That's the beauty of this platform, this GPT in a box solution I'm talking about. I know I told you last time I didn't like the name. I got to be careful of me saying that, but it should really be called NAI full stack because that's really what it is. You're getting a full stack solution. Okay, so you're not leaving anybody out. You don't have to have this shadow. They call it shadow AI now, another buzzword, right? Where the developer's going off to AWS and spending a ton of money, right? And you have the sprawl of you may not just money, but could be dangerous from a security perspective. What are they doing there? What data are they sharing or ingesting into AWS for it to work? Because AI is nothing without data, right? And your data is proprietary, right? So that's another side of it. So you're not leaving people out. You're bringing people together, right? And those people being brought together still have visibility into all of these things. Infrastructure will maintain operations. Oh, by the way, I didn't say this, but your cloud native folks, they could be we'll call it PE, platform engineers, will be here, right, at the NKP layer. So you have your infrastructure folks, your platform engineers, your storage folks, if they need to be, your DBAs, your data science, consuming an AI, right, creating endpoints, giving those endpoints back to developers to create Gen AI apps, and that is your factory right there. That is your AI factory. And this platform, by bringing teams together, really gets you to more of a value, right, side of things versus just a test and POC side of things. At one point, I'm going to get to a point where I'm going to walk through how to install all of this. I did this in pieces. If you started episode 1, I kind of did this in pieces with you a little bit, where I enabled NCI. Okay. I told you I had GPUs in NCI already. I showed you that. I implemented NKP. I implemented object services and file services. I installed NAI from NKP app catalog, right? And then I showed you some test applications, right? I did all this before. And This is something I did in a weekend. By the way, I didn't do this like every week. I didn't go back and say, okay, well, I'm going to take a week to do this, another week to do this. I did it all in a weekend, right? And this is me on hardware that's not even really certified, right? It's basically I'm using Nutanix Community Edition, and I'm running all of these things to show you the capability of the platform, right? The GPT in a box solution. So again, this is your AI factory, and I left this box up here blank on purpose because this is where I want to say. This is where I want to say. This is where your partners fit in. Okay, you'll have infrastructure partners, NVIDIA, Dell, Cisco, etc. Okay, you'll have partners around applications, AI applications like Data Robot, Codium, etc. Okay, and that's what I'm talking about with flexibility and choice, right? The ability to say, okay, and by the way, it doesn't have to be it could be just Intel as well. So I can just put Intel here because we do support AMX as well. But the reality is you have the flexibility to leverage any vendor basically for the most part that has a Nutanix validated solution, which most of them do now, right? Lenovo, HPE. So Lenovo has HX, HPE has DX, Dell has XC Plus, right? Cisco has hyperconverged compute. So all of these things, right? All of these solution providers you can select and choose to work with. Okay. I'm not saying, I know I said we don't care. We care in the aspect of, are you getting the best outcome? Right. So if you come to me and say, Mike, we really have a great relationship with Dell, right? We don't want to use Nutanix branded solution, which is a super micro solution, right? We want to use Dell, right? That's fine. You're not going to get any pushback from me because you're still going to be running Nutanix software on top of that. Okay. And you're still going to get the value. There's not going to be any difference in value from our perspective. Okay. Okay. So now that you have like your AI factory, what is it you're going to do with this? Right. Well, what you're going to do is you're going to really, generally, you're going to serve models. And you're going to serve models, right, through a few ways, right? You're either going to import your own, and most won't do this. You're going to get ones from Hugging Face, or you're going to use the NVIDIA NIM, right, as an example, or NEMO. Okay. And that's really what that is LLM ops. Okay. Now, there are still use cases for machine learning and deep learning, which is different than Gen AI and agentic AI, right? Machine learning is really more predictive AI, and there are use cases. And matter of fact, a lot of customers are already doing that today. And there's deep learning, right, which is part of, which is a neural network enabled deep learning, right, machine learning process, right? So you have on this side, we'll call this ML DL, right? Deep learning. And what you're doing here is, let's just do an arrow here. You have ML models or updated models. Let's just say updated ML models, okay? And you're basically doing model serving for those use cases. So one of the things I want to point out too, right, is if you decide to use NVIDIA, right, you're going to use NVIDIA accelerated computing down here, and you're going to use the AI Enterprise NIM and NVIDIA NEMO models, okay? And we have the ability to service those through NAI. If you decide to use Hugging Face, right, you can use Hugging Face, get the Llama models, right? All those models in Hugging Face, you sign up. You ask for permission for some of those models, right? They give you permission. You can use the APIs, the API key, whatever. And then we're able to tie in into NAI and automatically download those for you as well. And then you can manually import models as well. Okay. Now, None of this matters without what, right? None of this matters without data, right? Because data is the food for AI. Let's just call it that. I know it's kind of a simplistic way of thinking about it, but that's what it is, right? Without data, there is no AI. And you have data, right? Customers have a ton of data, but the question is your data AI ready? Okay. That's the first thing. And the second thing is, instead of moving data to AI, what about moving AI to data? Meaning bringing AI capabilities to where the data sits. Maybe it's in files, maybe it's in block storage, maybe it's in a database. And I'm not going to talk about that today. We'll talk about that in the next stream, about where Nutanix is thinking about AI use cases when it comes to where data sits, right? And not having to move data all over the place, but bringing AI to data. And we'll talk more about that. That's more of a roadmap thing that we're looking at. Okay. So in this case, you have Gen AI or agentic agents, we'll call it as well. And this is more machine learning, deep learning. Okay. This is really your AI factory. Because it encompasses all of the AI use cases, whether it's Gen AI, generative AI, agentic AI, or predictive AI using machine learning and deep learning. You can leverage this platform to do all of those things. Okay, and deliver the models to your developers and your application Gen AI applications very, very simply through this platform service within NAI. And then, of course, you have all the other infrastructure pieces and data services that allow you to do this. And they're not stitched together, they're integrated. That's the whole point of this, right? Whereas if you look at other solutions, and I would ask you to look at other solutions, look at Red Hat's AI solution, look at Dell's AI solution, look at all those solutions and ask them how this works. How do you serve up models? What does that process look like? Because we do it in one click. And that's the difference, right? Because the automation is already there. The other difference is, and people always ask us, why would I do this on-prem and not use the cloud? And we talked about this last time too. It's really around a few things. Generally speaking, it's around cost control, number one, right? Meaning I'm not paying by the drip every time I hit an API endpoint, a model inference endpoint. I'm not being charged for it. That's the first thing. You're only paying once, right? The second thing is, do I have data sovereignty issues? How do I control where my data sits? Is it secure? Over 60% of enterprise customers, this is a fact, say that their on-prem environment is more secure than the cloud. And so this is where your competitive innovation's happening, right? And so you want to protect that. This is your IP that you want to protect. The other thing is where your data lives, and as you move to the cloud, right? There's latency concerns there, right? You have better control of performance, right? Performance solutions, latency, all of those things on-prem, right? Every 60 miles you go, right, it's a millisecond in latency. So I just want to say that out loud. The last thing I'll tell you is you're now still able to deliver these greater than 5 nines capability back to your business. Okay, now if you do that in the cloud, you're bound by the shared responsibility model, right? Where the cloud will say, we can give you 4 nines or 3 nines availability, but now, Mr. Customer, you have to build your application layer to meet your greater than 5 nines SLA. Okay, that's cost. That's a lot of money to do that. And so what I would just say is think about those things as you go through this process. Now, I'm not saying the cloud is not a good use case a good substrate for this use case. Okay, in some cases, I talked about this the last time, is there was a customer I talked to that said, I don't really know what I need. Well, if you don't know what you need, but you're starting out somewhere, you have an idea, you want to test the waters with some things, the cloud's a great platform to do that. but still use NAI because we can control the cost from an API endpoint perspective. Okay. And then when you're ready to go from ideation POC to production, bring it on-prem, have full control, have a full integrated stack, and deliver that very simply, operate it very simply, and extract as much value as you possibly can. So I know I went over a bit, an hour. I went about 65 minutes, an hour and 5 minutes. Thank you for joining today. I hope you saw this as helpful as we talk about the Nutanix AI Factory, how the NVD helps in delivering from ideation POC into a value platform that's ready for to extract value from and ready to consume. And I look forward to talking to you and seeing you in the next session. So I hope you have a great day and a great productive week ahead. Thanks a lot.